My name is Travis Carless. I'm currently a doctoral student studying engineering public policy at Carnegie Mellon University. I'm currently investigating the competitiveness of nuclear power. Prior to my graduate studies, I used to live near the Cheswick Power Station in Pennsylvania. The area around the power station seemed very economically depressed. In keeping with my research, I began to ask myself, do communities around other baseload power plants such as nuclear and natural gas look the same? Now, typically, with electricity generation, we tend to compare them based on two measures: cost and emissions. Fossil fuel plants release hazardous emissions that have negative impacts on human health and contribute to acid rain. Carbon emissions from fossil fuel plants also contribute to global climate change. Though nuclear power provides about 62% of emission-free electricity in the United States, there are concerns of nuclear waste, radiation leaks, and Fukushima-level accidents. With coal, natural gas, and nuclear power, there are environmental and economic trade-offs between each technology. What if we decide to look just beyond cost and emissions and use the impacts on local communities as a metric when comparing these technologies? The goal of this work is to investigate and examine the relationship between socioeconomic community indicators with respect to distance and generating technology. In other words, how do communities around nuclear power plants compare against those around natural gas and coal? How do these technologies change the further you move away from a plant? How can we measure the public's perception of risk? Well, one way is to look at census data such as demographics, incomes, and housing information to see if these communities reflect the risk. We utilize ArcGIS in conjunction with 2007 to 2011 American Community Survey block group level data to analyze the characteristics of communities 0 to 5, 5 to 10, and 10 to 15 miles from each generating station. Within the analysis, we included community socioeconomic indicators related to population, education, income, and housing. Welch's and paired t-tests are used to determine the statistical significant differences between the community socioeconomic indicators with respect to distances and generating technologies. Within the Welch's t-test, the communities surrounding nuclear power plants are designated as the control group, while communities near fossil fuel plants are treated as two separate treatment groups. Similarly, within the paired t-test, the 0 to 5 mile investigation areas are designated as a control group, while the 5 to 10 mile and 10 to 15 mile investigation areas are treated as two separate treatment groups. To normalize our results, we take the ratio of the investigation areas and the county averages of each power plant. Our analysis finds that communities near nuclear power plants have a lower population of black residents and population densities than communities near fossil fuel plants. However, despite having no statistical significant differences in educational attainment, communities around nuclear power plants have higher incomes, home values, and lower poverty rates. For household incomes, communities around nuclear power plants tend to have larger incomes than their county averages. There are statistical significant differences in incomes within communities near nuclear power plants compared to coal within 0 to 5 and 5 to 10 miles, and natural gas plants within 5 to 10 miles. Looking just within coal, there are statistical significant differences as you compare communities 0 to 5 and 10 to 15 miles away. For poverty rates, communities around nuclear power plants tend to have lower rates than their county averages and fossil fuels. There are statistically significant differences in poverty rates within communities near nuclear power plants compared to fossil fuel plants within 0 to 5 and 5 to 10 miles. Within just nuclear power plants, there are statistically significant differences as you compare communities 0 to 5 and 10 to 15 miles. For home values, communities around nuclear power plants tend to have higher home values than their county averages and in some cases fossil fuels. There are statistically significant differences in home values within communities near nuclear power plants compared to fossil fuel plants within 0 to 5 and 5 to 10 miles. There are statistical significant differences as you compare communities 0 to 5 and 5 to 10 miles within coal power plants. There are also statistical significant differences in communities 0 to 5 and 10 to 15 miles within coal and natural gas. Based on the analysis, it can be seen that for this time period, nuclear power plants exhibit stronger positive externalities compared to fossil fuel plants. Home values, incomes, and poverty rates improve the closer the population is to a nuclear power plant. However, the opposite is true for fossil fuel plants. In those cases, these indicators remain stagnant or are worse. In the future, we would like to add a time dimension by performing this analysis using census data beginning with the 1970s.